Right. Hold out your arm for a second. Just look at it. Smooth skin, fine hairs lying flat. Now, imagine someone plays a piece of music that absolutely floors you, or you step outside on a freezing morning, or someone tells you a story that genuinely unsettles you, and suddenly those hairs stand up. The skin puckers, little bumps appear across your arm.
Goosebumps. Everyone gets them, everyone knows what they feel like, but almost nobody ever stops to ask, what is actually happening there? Why does your body do that? What is the point?
And the answer takes you somewhere completely unexpected, because goosebumps are essentially a message from your ancestors.
From our ancestors.
A reflex that made perfect sense hundreds of thousands of years ago that your body has stubbornly refused to let go of, even though it now does almost nothing useful for you whatsoever.
Almost nothing, because there are a couple of situations where goosebumps are still doing something real.
Right.
And one of them involves music in a way that tells you something profound about how your brain processes emotion and reward.
So let's get into it. Why do we get goosebumps?
To understand goosebumps, you first need to understand what they actually are mechanically, because there's a real physical process happening under the skin, and it's more interesting than most people realize.
Each hair on your body, and you have roughly 5 million of them covering almost every surface, sits inside a tiny structure called a hair follicle.
5 million, wow.
And attached to each follicle is a minuscule muscle, a tiny bundle of smooth muscle fibers called the erector pili.
Erector pili, Latin for roughly hair razor, which is exactly what it does.
Hair razor, okay.
And when the erector pili contracts, it pulls the hair follicle upright. The hair stands up. And because the follicle is anchored in the skin, the contraction also pulls the surrounding skin slightly inward, creating a small raised bump around the base of the hair.
Multiply that by thousands of follicles contracting simultaneously across your arms, your legs, your neck, and you get the distinctive puckered landscape of goosebumps. Each little bump is a hair follicle being yanked upright by its own tiny muscle.
And this happens involuntarily. You cannot choose to get goosebumps. You cannot will them into existence.
Can't control it.
The erector pili are controlled by the sympathetic nervous system, the same system that manages your fight or flight response. When the sympathetic nervous system fires, the erector pili contract. You don't get a say.
Which is the first clue about what goosebumps are really for. They're part of the body's emergency response system.
Right.
They're wired into the same circuitry as adrenaline, raised heart rate, dilated pupils, all the things that happen when your body perceives a threat or a sudden emotional surge.
Now, in humans, goosebumps are, let's be honest, fairly underwhelming. A few raised bumps on your forearm, not exactly dramatic.
But in other mammals, the same reflex does something genuinely impressive. Think about a cat that's frightened or threatened. The fur along its spine and tail stands completely on end.
Yeah, you see that.
The cat looks significantly larger than it actually is, more threatening, more formidable.
Or a porcupine raising its quills, same underlying mechanism amplified by the fact that the hairs are actually sharp spines. A porcupine with raised quills is a completely different proposition to a porcupine at rest.
Or a dog's hackles rising along its back when it senses danger. Same erector pili muscles, same sympathetic nervous system trigger, same effect. The animal appears larger, more aggressive, more dangerous.
This is called piloerection, from the Latin pilus for hair, and erection in the sense of standing upright. And across the mammal kingdom, piloerection serves two main functions: threat display, making the animal look bigger to potential predators or rivals, and thermal insulation, trapping a layer of warm air close to the skin.
The thermal insulation function is the one that still works in humans, to a small extent. When you're cold, your erector pili contract, your hairs stand up, and in theory, this creates a slightly thicker layer of air around your skin, a very modest insulating effect.
I say very modest because human body hair is so fine and sparse compared to, say, a bear or a wolf, that the insulating effect is essentially negligible. You are not meaningfully warmer because of your goosebumps. The reflex is there, it fires, and it achieves almost no visible result because the fur it was meant to raise is largely vanished.
which is what makes Goosebumps a textbook example of what evolutionary biologists call a vestigial trait.
A vestigial trait.
A feature that had a clear and important function in our evolutionary past, but which has become largely redundant as we've changed.
Our distant ancestors, early hominids, and before them the earlier primates from which they descended, were significantly hairier than we are today, and for them, piloerection would have worked properly. Fur standing on end when threatened would have made them look bigger and more dangerous.
As we lost our body hair, a process that happened gradually over hundreds of thousands of years, possibly linked to the need to regulate body temperature during long-distance running on the African savanna, the reflex didn't disappear with it.
The reflex just stayed.
The muscle stayed, the nervous system connection stayed, the trigger stayed. Only the hair that the whole system was designed to act on largely vanished.
So we're left with this ghost reflex. The machinery is all still there, firing away, doing its ancestral job, and producing almost no visible result because the fur it was meant to raise is gone.
It's a bit like still having the wiring for a lamp that's been removed from the room. The switch still works, the electricity still flows, but nothing lights up.
There's a related vestigial structure that's worth mentioning here. You know the small raised bump in the inner corner of your eye, the pink fleshy bit near your nose.
The placa semilunaris.
That's the remnant of a third eyelid, a nictitating membrane that many other animals still have and actively use. Cats, birds, sharks, some reptiles, they have a translucent third eyelid that sweeps across the eye horizontally, cleaning and protecting it while still allowing the animal to see.
Wow, a third eyelid.
In humans, it's just a small vestigial fold of tissue, still there, no longer doing anything.
Goosebumps, the plica semilunaris, the palmaris longus muscle in your forearm that about 14% of people are missing entirely. The human body is full of these evolutionary leftovers, structures that made sense at some point in our ancestral past and simply haven't been fully pruned away yet.
Evolution doesn't edit efficiently. It doesn't go back and tidy up. If a feature isn't actively harmful enough to reduce reproductive success, it tends to persist, sometimes for millions of years after it stops being useful.
Now, here's where it gets really interesting, because we've established that goosebumps from cold or fear are vestigial relics. But what about goosebumps from music? From a film scene that moves you? From a moment of profound beauty or awe?
That's a different thing entirely, and it has a different name. Scientists call it Frisson, from the French word for shiver or thrill, a sudden wave of goosebumps and a shiver-like sensation triggered by an emotional or aesthetic experience.
And Frisson is genuinely fascinating because not everyone experiences it.
Not everyone?
Studies suggest that somewhere between 55 and 80% of people report experiencing Frisson at least occasionally. But there's a significant portion of the population, perhaps 20 to 40%, who have never felt it at all.
That's a remarkable variation for something so fundamental. Most basic physiological responses are universal. Almost everyone shivers when cold. Almost everyone flinches at a loud noise. But frisson, chills from music, is something that some people experience deeply and others simply don't.
Research from the University of North Carolina found that people who experience frisson tend to score higher on a personality trait called openness to experience, one of the 5 major personality dimensions.
Okay.
Openness to experience is associated with imagination, intellectual curiosity, sensitivity to beauty and emotion.
The same researchers found that people who experience frisson also tend to have stronger connections between the auditory cortex, the part of the brain that processes sound, and the areas of the brain associated with emotional processing and reward.
So when a piece of music does something unexpected, a key change, a sudden swell of strings, a voice hitting a note you didn't anticipate, the auditory cortex and the emotional centers fire together intensely, and the result is dopamine release, a genuine reward signal.
Ah, so it's a reward.
And the body responds with the same sympathetic nervous system activation that produces goosebumps in cold or fear.
It's the brain's reward system being triggered by aesthetic surprise. The music did something you didn't predict, and your brain rewarded you for noticing. That reward signal is strong enough to activate the same physical response as a threat or a cold snap.
Which is a genuinely extraordinary thing when you sit with it. The same physical mechanism your ancient ancestors used to puff up their fur against a predator, you are now using to respond to a violin reaching the top of its range in a darkened concert hall.
The gap between those two things is the entire distance of human civilization.
There's a specific musical technique that reliably triggers Frisson in people who are susceptible to it, and composers have known about it intuitively for centuries, long before neuroscience could explain why it works.
Unexpected harmonic shifts, sudden dynamic changes, a piece that's been quiet for a long time suddenly becoming loud, or vice versa. A solo voice or instrument suddenly joined by a full orchestra. The entry of a choir, a melodic line rising higher than the listener expects.
Beethoven's Ninth Symphony is one of the most cited examples, specifically the moment in the fourth movement when the chorus enters for the first time. After nearly an hour of purely instrumental music, suddenly the human voice fills the room.
Yes.
Or Barber's Adagio for strings, which has been repeatedly voted one of the saddest pieces of music ever written, and which reliably produces frisson in susceptible listeners through its slow, aching melodic climb and its use of silence before resolution.
Or more recently, any number of pop or film score moments. The key change in a power ballad, the moment in a film score when the theme returns at full volume after a quiet, tense sequence. Hans Zimmer has built an entire career partly on knowing exactly where to place these moments.
And interestingly, the more familiar you are with a piece of music, the more you can anticipate where the frisson triggering moment is coming. And paradoxically, that anticipation itself can trigger the response before the moment arrives.
The anticipation. Your brain starts releasing dopamine in advance, in expectation of the reward.
Which is why a piece of music you know well can give you chills at the same moment every single time. You know it's coming, and your brain rewards you for the anticipation as much as the event itself.
There's also research suggesting that shared emotional experiences amplify frisson. Experiencing powerful music in a crowd, a concert, a stadium, a cathedral, produces stronger responses than the same music heard alone.
The crowd effect.
The awareness that other people around you are having the same emotional experience adds another layer of signal that the brain treats as meaningful.
This may be connected to the social bonding functions of music, the idea that music evolved, at least in part, as a way of synchronizing the emotional states of groups of people, creating shared feeling, tribal cohesion, which would explain why live music has always felt qualitatively different from recorded music, even when the recorded version is technically superior.
You're not just hearing sound, you're participating in a collective emotional experience, and your body registers that with the same ancient reflex it uses to respond to cold and fear.
One more thing worth knowing about Goosebumps, and this one surprised me when I came across it. Goosebumps may not be entirely useless after all, even in modern humans. There's recent research suggesting that the erector pili muscles play a role in hair follicle regeneration.
A study published in Cell in 2020 from researchers at Harvard found that the erector pili muscles are physically connected to stem cells in the hair follicle, and that the mechanical stress of the muscle contracting actually stimulates those stem cells, activates them.
Which means that goosebumps, the contraction of the erector pili, may be part of the mechanism by which hair follicles repair and regenerate themselves. The reflex that we thought was purely vestigial might actually be doing quiet maintenance work on the hair follicles it's attached to.
Evolution left the machinery in place, and it turns out the machinery was still doing something useful, just something we couldn't see until we had the tools to look closely enough.
Which is a good reminder that vestigio doesn't necessarily mean useless. It means the original function has changed or diminished, but biology is endlessly resourceful. Structures get repurposed, reflexes get redirected.
Your ancestors' threat display became your response to Beethoven. The muscle that was meant to make fur stand on end is quietly maintaining your hair follicles. And somewhere in the gap between those ancient functions and these modern ones is the whole story of what it means to be human.
That's the kind of thing that gives you goosebumps, really.
It absolutely is.
Thank you so much for listening to the Why Behind Everything. If you've enjoyed this episode, please do subscribe on YouTube. It genuinely helps us reach more people who are curious about the world.
And next time, we're asking, why do we whisper in libraries? It turns out, libraries haven't always been quiet places. The rule of silence has a specific origin, a specific moment when it was enforced, and the story behind it touches on power, class, and what we've decided knowledge is actually for.
See you then.